Hey guys, this is your next set of notes for Unit 3. This is on history of the atom, a little bit of history of chemistry, and just knowing a few of the scientists that contributed to that. So first, I just want to review a little bit of what we talked about last class. Please remember that this number at the top is your atomic number. It will not always be at the top. It could be in a different spot depending on what periodic table you have. Then I have the symbol, the name, and lastly I have the atomic mass. So remember that the mass is your decimal number. Your atomic number can also give you the number of protons and the number of electrons. So I have 6 protons and 6 electrons in this case. Okay, there is a video that I really like. It's a TED Ed video. It's on the class website, so please go and watch that after this one. So our first scientist is Democritus. He was alive from 460 to 370 BC. He said that matter is composed of tiny indivisible particles with nothing between them but empty space. He called them atoms, and it's from I think it's Greek or Latin. Atomos means uncuttable, like you cannot cut an atom in half. The points to his theory were that all matter is composed of atoms. There's a void or a space between the atoms. Atoms are going to be completely solid. They're homogeneous, meaning they look the same throughout. They differ in size, shape, and weight. And then he said that atoms are the building blocks of life. So a few of these things he was correct on, some of them not so much, but still he had some good guesses and some good theories for that time period. Our next scientist is Aristotle from 384 to 322 BC. He said that it was impossible for nothing to exist. So he's saying that even in the deepest parts of space, where it seems like there's nothing at all, there's still atoms. Next is John Dalton. He was alive from 1776 through 1844. In 1803, he came up with the atomic theory, and it has 4 postulates or parts. The main thing you need to know about them is that he came up with this theory. It has 4 parts, and then maybe be able to kind of summarize the parts or basically know what each one is saying. So number 1, all matter consists of atoms, tiny indivisible particles that cannot be created or destroyed. Number 2, atoms of one element cannot be converted into atoms of another element. Number 3, atoms of one element are identical in mass and other properties and are different from any other atoms of any other element. Compounds result from the chemical combination of a specific ratio of atoms of different elements. So number 1, he's saying they can't be created or destroyed. Number 2, he's saying if I have a carbon atom, I can't convert that into a hydrogen atom. It's always going to be whatever element it is. Number 3, so if I have oxygen gas, all of the atoms in that are going to be oxygen. They're not going to be some other kind of atom or from a different element. Number 4, compounds have a specific ratio. So that's like saying H2O, a water molecule will always have 2 hydrogen and 1 oxygen. It's always going to have that specific ratio. Next we have J.J. Thomson from 1856 to 1940. In 1897, he had an experiment where voltage was applied across 2 wires, also known as electrodes, in a vacuum tube, so no outside forces were occurring. A glowing beam of particles was observed to travel from the cathode, the negative side, to the anode, the positive side. The glowing beam was named the cathode ray, and those rays tend to move toward a positive charge. So he thought that they were made of negatively charged particles. Because remember, like a battery, your positive and negatives are not like a battery or a magnet, your positive and negatives are going to attract. He concluded that atoms had negatively charged particles called electrons. So he came up with this plum pudding model of the atom. So plum pudding is kind of an English thing, or like in Great Britain. Basically, it kind of looked like a pie or a bowl of pudding, and then the little specks on top would be pieces of plums. So his model, he said, was like a large positive area, and then it had small electrons just spaced throughout. Next, we have Ernest Rutherford, who was alive from 1871 to 1937. In 1911, he came up with the gold foil experiment. He shot alpha particles, which were positively charged, through a thin sheet of gold foil. Most of the particles passed right through the foil, and that's what he assumed was going to happen. But some of the particles bounced back and went at different angles. He concluded that the plum pudding model was wrong. His experiments also concluded that atoms had an inner core called a nucleus, which contained most of the mass of an atom and was a positively charged space. He discovered or came up with the nuclear model, which is kind of what we think of when we talk about atoms. He said that atoms have a very small positively charged nucleus, and that's where most of the mass is. There's positive charged particles that are called protons. The atom has mostly empty space. Electrons are attracted to the nucleus but stay outside of it. So he was pretty close, right, in his thinking. Next, we have Niels Bohr. He was alive from 1885 to 1962. In 1913, he came up with the planetary model, which we now just call the Bohr model. He said that electrons orbit the nucleus in circular patterns. In other words, they're in a fixed orbit, so they stay on their own path. You can think of how Earth is orbiting the sun. We're staying in a circle and not going out of it. The amount of energy determines the electron's distance from the nucleus. The greater the energy, the farther away from the nucleus the electrons orbit. Each electron is associated with a specific level of energy. An electron can absorb a quantum of energy to become excited and move to a higher energy level, which would be farther away from the nucleus. But when those electrons fall back down to their ground state, or whichever level they were in originally, they emit energy as light. That's called electromagnetic radiation. So that light could be in different colors. He also said electrons can only exist in certain energy levels. Today, we use the modern quantum theory. It's based off of Bohr's model. A little bit of it comes from that nuclear model. Electrons move more in a cloud, not in set circular paths. And this also describes energy levels for all elements and their probable location of electrons within energy levels. And we will talk about those energy levels more at the end of this unit and into next unit. So that's all.